Hey everybody, how you doing today? Last lesson of this mini chapter, chapter 9, and today is infinite geometric series. So, yesterday we were doing just normal geometric series, but what if that geometric series went on forever? Well, as we're going to talk about in class, it only works if the rate, if what you're multiplying by is less than 1. But if you have a geometric series and r is less than 1, then s infinity is always going to be equal to a over 1 minus r. And we will talk about where that formula comes from in class on Wednesday. First example here. So I have 12 plus 8 plus 16 thirds plus yada da 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 da. And we're looking, because it just says dot 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 and it doesn't give us an ending point, they are asking for s infinity. So s infinity equals to a, the first, it'll just say a, but they really mean a1, but you'll frequently just see a, and if you just see a by itself, it's okay, it's just a1. But in this case, it's 12 divided by 1 minus the r. What are you multiplying by to get from number to number? As I mentioned yesterday, go the second number divided by the first number. 8 divided by 12, that works out to be 2/3 if you divide out of 4. Or if I did 16 thirds divided by 8, that's kind of confusing. But so what you do is you multiply by 3 over 3 to eliminate the fraction on top of the fraction. And you get 16 over 24, which is also equal to 2 over 3. So you got the same rate, so I know that r is equal to 2 over 3, so 1 minus 2/3. That becomes 12 over 1 minus 2/3, that's equal to 1/3. And dividing by 1/3 is the same thing as multiplying by its reciprocal. So the reciprocal of 1/3 is 3. 12 times 3 is 36. All right, number 2. Now, number 2, landmine problem. 2 plus 6 plus 18. Oh, okay, it's geometric. It's going dot, dot, dot. They want the s infinity. Do you know what the problem is? There's a problem. There's a big problem with what I'm doing right now. See if you can catch what this big problem is. A1 is 2 over 1 minus the r. Looks like we're multiplying by 3. Oh, I'm going to go back to this quick example just for showing notes. I forgot to show here that I was multiplying by 2/3. 2 times 3 is 6. 6 times 3 is 18. So the rate is 3. And let's see, I get 2 over 1 minus 3, which is negative 2, so the answer must be negative 1, right? Common sense your way through it. 2 plus 6 plus 18. It's getting bigger and bigger and bigger and bigger. It doesn't make sense that the answer would be negative. Why is the answer negative? Well, the rule states r must be less than 1. In this case, r is not less than 1. R is bigger than 1. Which means that this is impossible. You cannot do s infinity, because if you kept going on and on and on and the number kept getting bigger and bigger, s infinity would just be infinity. So cross this out. No solution. Why? Because r is greater than 1. While I'm thinking about this, it is possible for r to be negative but still be less than 1. So up here I should actually say the absolute value of r needs to be less than 1. Because if r equals negative 1/3, that's still okay. But if it's equal to negative 2, that's not okay. So it's got to be geometric. R's got to be less than 1. Number 3. 2 plus 2.5 plus 2 plus 1.5. All right, there's something also wrong with this problem. See if you can figure out what's wrong with this one. Let's see, dot, dot, dot. So that means I'm looking for S infinity. And in this case, well, I noticed that it keeps going down by 0.5 every time. So negative 0.5, or so I guess my R could be a negative 0.5. So A1, 3 over 1 minus negative 0.5, or negative 1/2. I'm going to use negative 1/2. 1 minus negative 1/2 is the same thing as 1 plus 1/2, which is 3/2. 3 divided by 3/2, it's the same thing as 3 times 2/3, which is equal to 2. All right, what's wrong? Did you see what's wrong? Because I did get an answer, but let's common sense our way through it. If it keeps going down by negative 0.5, negative 0.5, negative 0.5, negative 0.5, negative 0.5, you eventually reach 0, and then you start going to negative 0.5, negative 1, negative 1.5, negative 2. So all of these values would eventually be canceled out by the negative values, and then it would keep going negative 0.5, negative 0.5, and you're also adding all those numbers together. The answer should be negative. Like negative infinity, I would think, but I kept getting positive. What's the problem? Not geometric. This one's arithmetic. So be really careful with these S infinity problems, because it has to be a geometric and R has to be less than 1. This isn't even an R, it's a D because it's arithmetic. So just like number 2, no solution. Why is there no solution? Because it is an arithmetic series. So this whole thing only works on geometric series. Last one, number 4. I like problems like this. Find S4 if S infinity is 7.5 and the R equals 1/3. So you start off with your S infinity equation. S infinity equals A over 1 minus R, and you plug in everything you can. S infinity becomes 7.5. The R becomes 1/3, and I'm looking for the A1 term, 1 minus 1/3. All right, 7.5. I'm going to change that to 15/2 for solving this problem. It's going to make it easier. Over here I have A divided by 2/3. And to solve for A, you can multiply both sides by the denominator, so multiply both sides by 2/3. 2/3 cancel out, and A is equal to 2's cancel out, and 15 divided by 3 is 5. So A is equal to 5. And now I could use the S formula, the S normal formula. So Sn equals A times 1 minus R to the n all over 1 minus R. And S4 is equal to the A term, which is 5, times 1 minus 1/3 raised to the power of 4, all over 1 minus 1/3. All right. Let's see. I'm going to go with non-calculator as long as I can. 1 over 3 to the 4 is 1 over 81. 1 minus 1 over 81, that's 81 over 81 minus 1 over 81, so 80 over 81. And if you multiply that by 5, I'm getting 400 over 81. Oops, side work, sorry about that. I'm going to zoom out here. Okay, so then all of this is being divided by 2/3. So I have 400 over 81 divided by 2/3, which is the same thing as multiplying by 3/2. This becomes 200. That becomes 27. So I think my exact answer, S4, is 200 over 27. And you could always use your calculator to check it out for you, especially if they're asking for an exact answer, huh? So let's see. I have 1 divided by 3. That's raised to the 4th power. So I have that. Then 1 minus that thing gives me that times 5 divided by 2/3. So 2/3. And let's see, it gave me 7.407, and the 407 is repeating. And then I could always test that out. 200 divided by 27 equals, same thing. Okay, so if they ask for this answer and they ask for an exact answer, a fraction is always the best way to give an exact answer. But a repeating decimal, as long as you put the little line over it, it does keep the equality. You don't have to drop it down to an approximation. So, all right, everybody, that's that for this lesson. I hope you enjoyed it, and I hope you're having yourselves a great day, and I will talk to you soon. Bye-bye.